this video, attempted to create a drone that is very stable. This means while flying it, my whole goal was to make sure that it could maintain orientation and not wobble around. The reason why this project is really important is because a lot of drones have a hard time maintaining orientation, but my drone can maintain orientation by itself, which makes driving the drone a lot easier. The parts of this project consisted of a drone frame, which I bought, some plastic propellers, 4 brushless motors, a GPS chip that can track the drone's location, 4 speed controllers, a Speedy B flight controller, a 3S LiPo battery, a power distribution board which makes sure that energy from the LiPo battery distributes power to all 4 motors evenly, and finally a receiver which makes it possible to actually fly the drone. Now let's get into how I constructed the drone. First, I assembled the drone frame using the instruction manual that was given to me. I then plugged each of the 4 motors into the speed controllers and then mounted them, both the motors and speed controllers, on the drone frame. I then mounted the power distribution board on the drone frame and then soldered an XT60 connector to the power distribution board. I did this for all 4 speed controllers. I then soldered the receiver, making sure that the wires went to the right paths. Now to mount the flight controller, I first mounted this black piece of plastic on the power distribution board, and then I mounted the flight controller on top of the black piece of plastic using double-sided tape. I also connected the 4 speed controllers and the receiver to the flight controller so that the receiver and the motors would have power to run. I then made sure the motors could actually spin using the remote control, and they did, but unfortunately the drone did not fly very well. The reason being is because the drone at the time didn't have the GPS installed. So I realized that once I installed the GPS, the drone would become a lot more stable, which is the goal of this whole project. And I made sure to plug the GPS into the 5-volt slot of the flight controller, as you can see here. In the end, the final product of the drone looked like this, and it flew quite well, as you'll see in the next videos. Alright, as you can see here, the drone is floating, and I'm not touching the controller at all. This is what you call position hold, and yeah, it works. I'm not touching any of the sticks. So this is another example of position hold, and basically what position hold is it allows the drone to maintain stability and stay in one exact location for several minutes. So this right here is an example of altitude hold, and it basically allows the drone to move up and down without deviating in any horizontal direction. And the drone is very stable as well, because I am putting in very little effort in bringing the drone down. So in terms of the software, there was actually a lot I had to do. This ranged from setting up the motors to setting up the GPS, barometer, and other sensors. And the software I used was called iNav Configurator. So one of the main things I had to do was set up the motors, and you'll see here it says S1 through S4. That's basically where I plugged each speed controller into the flight controller. So I plugged 4 speed controllers into locations S1 through S4 on the flight controller. And each speed controller is connected to its own motor. So right here are 2 important features I had to set up for when the drone takes off. So the first one is called arming, and that basically gives the drone a little bit of spin, a little bit of power to start it up. And then the next one is called angle mode, which basically makes sure that the drone is horizontally leveled before it starts taking off into the air. These two features are important because they promote drone stability when it first takes off. So the next two features I had to develop were position hold and altitude hold, and they were actually showcased previously in this video. So what you are seeing right now are the sensors I had to use. They consisted of a gyroscope, accelerometer, magnetometer, and barometer. And as you can see, the accelerometer and magnetometer are going crazy right now because I'm actually moving the drone. And I also had to use a GPS. So right here is the end product of how the drone flies. Overall, uh, in terms of achieving the goal of making a stable drone, I say I did pretty well, but it could definitely fly a lot better because sometimes it's a little hard to control just because of how the sensors work. Therefore, I say that this project is a success, but it could use some improvement. Thanks for watching.